With the passage of President Biden's infrastructure law, a bipartisan effort in Congress, Pennsylvania is receiving $245 million annually for 15 years to address abandoned coal mines and their pollution. Passive treatment systems are one way Pennsylvanians are treating acid mine drainage. Today, we are in Somerset County at the rehabilitated Oven Run B passive treatment system to learn how technology is improving these systems. Oven Run flows into the Stony Creek River, and over the years, several passive treatment systems have been built, and they have enabled about 20 miles of the Stony Creek River to once again support fish and water recreation.
So we're at the Oven Run B passive treatment system, which was originally built back in 1999, and it's since been rehabilitated. And the water that we're treating here comes out of abandoned underground coal mines, which when the original system was installed, they dug back into the hillside, opened up the mine voids and pushed perforated pipes to allow the water to flow into the treatment system. So there's a lot of flow that we're capturing that just gets directed into here, because otherwise it would have pushed that clay liner and destroyed it. And over time that's going to plug up because of the low pH iron, and it's just going to come into these ponds, and that's okay. And like, you never get it all. As part of the rehabilitation process, we wanted to be able to monitor flow as it comes into the treatment system. So we collected it in what we call a moat, which is just basically a shallow channel, and then direct it into a flume.
Tim, what is it we're looking at right here?
Well, this is a flow measurement device, which is a typical H flume that's used for monitoring flow. But here at Oven Run, because we wanted to be able to know how much water was coming into the treatment system at any given time, we put an ultrasonic meter that feeds a flow instrument in this box here that records the flow continuously at the site. Which it's important to us because with these passive treatment systems, sometimes they get overwhelmed if there's too much flow coming into the treatment system, and it's critical to know that for maintenance purposes, whether we need to do something or just wait for it to stop raining. Okay, at Oven Run, what we decided to do is deploy a digital monitoring system. It's all solar powered, and instruments like flow monitoring, solar powered automatic valves, and pH meters all feed information through a cell phone signal up to the cloud so that we can check the health of the system from our desktop.
Tim, it's my understanding there were some site difficulties that you had experience with. How did they complicate the design, and how did you address those difficulties?
One of the big issues that we had at the site before we rehabilitated it was that this was a single treatment cell. And we have found over the years that really large treatment cells can often lead to maintenance and operation issues. So what we wanted to do was to divvy up the treatment among 3 different automatic flushing vertical flow ponds. But in order to do that, we had to separate the flow evenly among 3 ponds. This site was built on an old coal mine site, and there was a sandstone bedrock layer that didn't allow us to excavate these ponds any deeper, so we had to use a larger diameter pipe to allow the water to be flushed from the holding pond into the 3 vertical flow ponds. Each one of those contained 3,000 tons of limestone, so when we flush water in, we're flushing about 200,000 gallons, and we want to do that relatively quickly because one of the technology advancements that we took at this treatment site was we found that if you flush the water into the limestone, hold it for a certain amount of time, and then flush it out, you get better treatment or more acid neutralization per ton of limestone than if you just let it gradually fill up over time and then flush out, let's say, once per day. So we used automated valves to do 2 things here. The automated valves dispense the water among the 3 ponds evenly. So we flush water in at midnight into pond 1, at 8 a.m. into pond 2, and then later in the afternoon into pond 3. And each one of those ponds holds the water for 12 hours, and then it flushes into the settling pond. We've used these valves on other sites, but one of the issues that we have is sometimes, because they are mechanical components, sometimes we have failures and you'll come out to the site and something's not working. So we were able to use water level sensors installed in the AgriDrain smart drain boxes to allow us to know if the fill valves are working and also if the flush valves are working. And all of that is hooked up to our central telemetry unit that allows us to monitor the functions of those 6 valves remotely. So we don't have to come out to the site because it takes, two hours to get out here just to troubleshoot issues. And during system startup, we had one of our 6 valves had a fault and it wasn't working. We were able to tell where the problem was, and then look at the monitoring data to zero in on what the problem was, and it ended up being a relay socket that we were able to swap out and then fix it. And since we fixed it, the system has been functioning very well since then.
Tim, you're standing in front of the automatic flushing system that uses solar power to flush the valve. Could you tell us why that's important and how it works?
Sure. So at this site, we use the first step of treatment is an automatic flushing limestone only vertical flow pond. And the way they work is that the raw mine drainage enters the limestone and then it dissolves. So just like taking a Tums, which is calcium carbonate, limestone is calcium carbonate, and it neutralizes the acid. As the acid is neutralized, the pH rises, and then you precipitate iron and aluminum particulates that will get collected in the limestone of the vertical flow pond. Because this happens, what will eventually happen is the limestone will plug up over time. And so we've utilized these AgriDrain smart drain valves in order to flush the ponds at least once per day. And so what's in these boxes is that there's a solar controller that provides power to a battery, and then a programmable controller in here that runs an automated valve in the AgriDrain smart drain. It's just a linear actuator that raises and lowers a valve at a set point. So this opens and closes once per day. And we found these to be very effective in taking the solids that form in the limestone and flush it into the settling pond, thereby reducing the amount of maintenance needed on the limestone only vertical flow ponds. So when these malfunction, because they are mechanical parts, they can malfunction at times, the level of treatment that you'll see will drop off. And so we wanted to be able to monitor this treatment site remotely, over a web-based application. So we installed a water level sensor in these AgriDrain smart drains that allows us to know when the fill valves fill the limestone and also when the flush valves flush the limestone. One of the important things, this site is 2 hours away from our office. To come out here, it's very expensive and time consuming to be able to do that. On one of these boxes, one of the 6 that we've had, one of the relays was malfunctioning. And so we were able just to look at the monitoring data from the water level meters and zero in that we had a sporadic problem. Sometimes it worked and sometimes it didn't, but we were able to figure out it wasn't the charge controller, it wasn't the battery, it wasn't the solar panel, it wasn't even the programmable radio. It was actually a socket of one of the relays. And so it was like a $14 part that we were able to diagnose, from our desktop, saving us a lot of time and money figuring out what's wrong. We've since replaced those relay sockets, and the system's been working since we've done that. So we are standing at the flow distribution box here at Oven Run. This concrete box at Oven Run, we used it because we had to use these AgriDrain smart drain valves, and all of them would be sticking up above grade because of the limited amount of drop that we had from the holding pond to the first set of 3 vertical flow ponds. So in order to protect them from the weather and hunters and animals, we decided to put it in a precast concrete box to provide a place where we can mount our solar panels, house our electrical equipment, as well as the valves. And what's happening beneath my feet is that we have an 18-inch pipe that comes from the holding pond over by the mine discharge, and then there's 3 outlets to that manifold. Each one is connected to an AgriDrain smart drain that has a 12-inch valve in it. And each one of these valves feeds one of the limestone only vertical flow ponds. And so every 8 hours, one of them will open and fill the limestone in an auto flusher. And the other thing that's happening in this box is that we have our central telemetry unit here, where we take the various sensors. We have 2 pH monitoring stations, a flow monitoring station, and then 3 water level monitoring stations at the vertical flow ponds that feed that data into a central telemetry unit that pushes it up to the cloud and allows us to record the pH at the outfall, the pH midway through the system, and also the flow coming in, as well as monitoring the function of the 6 automated valves, 3 of which are here. These are the fill valves, and the 3 other valves are at the outlet of the automatic flushing vertical flow ponds. The water quality here at Oven Run is so severe that we do a 2-stage acid neutralization. The first step is the auto flushers, and it comes into a settling pond. We actually have a series of 2 settling ponds, and then we split the flow into 2 different Jennings type vertical flow ponds. And what makes them a Jennings type vertical flow pond is that technology was first deployed and invented at the Jennings Environmental Education Center, and instead of using a layer of compost or compost amended with limestone overlying a layer of limestone underneath, we actually mix it all together and we add wood chips. So the treatment media in a Jennings pond is a mixture of limestone with an equal volume of organic material, where 2/3 of that volume of organic material is wood chips and 1/3 of it spent mushroom compost, and that's all mixed together to help keep, if it's still ferrous iron, it'll pass through that treatment system and not necessarily precipitate. But also mixing it with the organic matter prevents short circuiting, and it also creates an environment where we've got a lot more alkalinity generation and acid neutralization happening per volume of treatment media. So we get really good treatment in these Jennings ponds. And what's great here at Oven Run is that if we do have an issue with our upstream components, the Jennings ponds will pick up the slack, and they'll basically treat as much acid as you put into them. It will reduce their design life if you do that. So that's why we have the 2-stage process. And then, one of the technology advancements we did at Oven Run here is we actually have a pH meter that's measuring the pH going into the Jennings ponds. So that tells us how well the auto flushers upstream are working, and then also tells us if we're starting to overwhelm the Jennings ponds. And we can do that all sitting at our desk in our office in Mars, Pennsylvania, as opposed to driving 2 hours out to Somerset. So that allows us to know if both parts of the treatment systems are working, and if we need to get out here and do anything with it. And instead of coming out, typically once a month, we can check on these things every day, just in a few minutes, just pulling something up on our computer, and that lets us know if this giant treatment system is working or not without having to drive out here. So that's a tremendous savings in manpower and also operation cost, being able to monitor this just remotely.
Is there still a need to have someone come out, say once a month, to visually look at things to see if there was any vandalism or any stormwater damage or anything like that?
Sure, yeah, on site, yeah, like the pH meters and the flow meters and the sensors aren't going to tell us if there's been vandalism. So once a month is a good practice to have, and what we're hoping that once this, the remote monitoring technology kind of gets proven, that we can reduce that to once a quarter. And one of the things that you'll have to do at that point is calibrate the pH meters, because they do drift. And so calibrate the pH meters once a quarter, and then if we do see an issue, then we come out here and assess like what needs to be done. But a site like this, we were thinking about putting an active treatment system out here, which would be a tremendous amount of maintenance, but we're treating on average 500 pounds per day of acidity. So if this system isn't working, it's going to have a big impact to the stream. So by remote monitoring all of this, we're able to prevent pollution from entering the stream and stay ahead of the maintenance by monitoring that pH, because we take continuous pH measurements so we can see if there's a trend, where if you just came out here once a month, you'd have a single pH. And if something malfunctions, in between your site visits, you don't necessarily know that that's what's happening. So what we're seeing here is the water from the second settling pond entering the straight pipe there, which has a pH probe submerged down into that pipe that allows us to monitor the health of the first step of treatment in the system. And then we have 2 10-inch 90-degree elbows that we can rotate and balance the flow among the two Jennings type vertical flow ponds. And so if we need to do maintenance on one, we can just rotate that elbow up and push all the flow into the other one, do whatever maintenance is needed, and vice versa. And so what this allows us to do is to tell if the first part of the treatment system is working as intended, and that pH meter is connected via a radio to our central telemetry unit, giving us real-time continuous pH readings, and that allows us to see how well the treatment system is working, and again helps guide our maintenance decision, giving us a lot more data than if you were just coming out here, let's say once a month. Or I mean, to get the amount of data that we're gathering from these remote sensing technologies, you'd have to have somebody out here on site every day. Ballpark costs $200 to $300 per site visit. Yeah, when you figure in mileage and people's times, and then just the overhead that goes along with it. So you can do that entire site assessment remotely in a matter of just a few minutes, saving a tremendous amount of time and also giving you a lot more data to help guide decisions on a treatment system. That literally cost $1.5 million to rehab. Trying to make those decisions and figure out what needs to be done. When we have data like that we're collecting here, it will save us money in the long run as far as doing the maintenance work. Not to mention that it is a heck of a lot cheaper to be, brewing your coffee and checking your data at your computer than driving 2 hours in the middle of winter out to the mountains in Somerset. 6-inch riser pipe coming up, and then a 4x6 fern co, and then we have a 4-inch elbow that's put in there. And what that allows us to do is balance the flow among the 4 cells of the underdrain system. Because in these larger treatment ponds, if you have a single manifold, one lateral pipe, one perforated pipe feeding that header pipe that goes out of the pond, you can have all your water flowing down from the water cap down through a small portion of the treatment media and then out of the pond. So the larger the ponds are, the more sections of underdrain pipe that we put in, and that allows us to ensure that more of the treatment media is being utilized. And then because we use organic material here, you can get a lot of hydrogen sulfide odor, which has been problematic at systems that are closer to residences and towns and whatnot. And so what we're able to do on the newer systems is that we can lower one of the cells and raise the other one, so that we basically turn down the treatment system and reduce that hydrogen sulfide odor, which we've had to do on a number of systems over time. And like right now, this is the way it would be standard operating procedure, where all 4 cells are being utilized. So all that water is getting distributed across the entire pond, going down through the treatment media, collected in the 4 cells of the underdrain. Those come out through the embankment, and then we have the risers pipes, and then beyond that we also have a valve that allows us to drain the ponds whenever we need to do maintenance. So, and then we just follow that up with one final settling pond that has directional baffles in it, so that we maximize the retention time in the pond itself.
So how do you know the system is working well all the time?
Okay, that's a great question. So this is the final settling pond. It's after our second set of vertical flow ponds, and we installed a pipe in the existing treatment pond embankment that goes out to the treatment system outlet. That pH meter tells us if the pH leaving the system is good, which if it drops, that will indicate that there might be metals leaving the treatment system. But if that pH stays above a 7, typically all of our iron is removed. We take out 25 parts per million of iron with this treatment system. We take out about 20 parts per million of aluminum with this treatment system. And as long as we have a good pH leaving the system, that's a strong indication that all of those pollutants are being prevented from entering the stream. Because if that pH were to drop to the raw pH levels, which is about 2.8, going into the stream, we would likely have a fish kill. And so we're able to monitor this remotely, just pull it up on our computer, and we know if the system is working good enough or not. And then we'd follow it up, a couple times a year. We'd come out here and take some water samples to confirm that everything is still working right.
Thanks everybody. Our tour of the Oven Run B system is one of a series of acid mine drainage passive treatment systems where the investments have been made in Oven Run and in the Stony Creek watershed. Those systems have been successful, and this one's going to be successful for a couple of decades to come based on the technology that's been in there. And this investment has transformed a polluted waterway into a recreation destination for anglers, kayakers, and those who love the outdoors. It has gone from an economic liability to an economic asset, a local revenue generator, because when you get right down to it, clean water is the ultimate infrastructure.